Hi everyone, can you all see the whiteboard?
Yes.
Okay, what answers did you get for the first question? Okay, good. 336 is correct. Let's see. Ahana, can you explain?
Okay, so I drew a rectangle and I put and then I drew some posts at each of the four corners.
Mhm.
Then I drew the rest of them, making them all have an equal space between them.
Mhm.
And then I I counted the number of I did 4x7 for the long side and 3x4 for the short side, and I got 28 and 12. And I multiplied those two together and it got 336.
Good. Okay, so 4 by 7 and 4 by 3. So how did you know there were 7 posts on this side or that there would be like 7 gaps on this side and 3 on this side?
And I counted I just counted the number of spaces.
Mhm.
So that's how I got it.
Okay, good. So if there's 7 spaces, we know that there should have been 8 posts um, on this side, and then with 3 spaces, there's 4 posts on this side. So this satisfies because we know that the longer side, including the corners, has twice as many posts as the shorter side. So I think one way that we can find this is we can draw it out and we can see that this should be 8 and 4. Another way is we know that there's a total of 20 posts, right? So that means that if I just consider this side, so half of those 10 posts will cover um, this side and this side. Let's say we don't include one corner, which goes to the other, this and this would be the other 10. So if we want to include all the posts on this side plus all the posts on this side, we would need to include one extra for this corner. And this corner actually gets counted 2 times, right? In this side as well as this side. So there's 2 extra there, plus 2, equal to 12 posts. If I add up the number of posts on this side and this side. And if we know that this side has twice as many posts as this side, since we're including the corners, if it's a total of 12, this must be 8 posts, and this must be 4 posts. And once we know the number of posts, there should be one less gaps between the posts. So for instance, if we draw the 4 posts here, so there's already 2. This is the third one, this is the fourth one. So there's 3 gaps here between the 4 posts, 1, 2, 3. Each would be having 4 yards. So 4 times 3, this is 12 yards. And same thing on this side, we have a total of 8 posts, so 6 more in between here, creating 7 gaps. So 4 times 7 is 28 yards. And this is 12 yards. So the product 28 times 12 gives us 336. Any questions on this? Okay, let's move on to the next question. Wow, okay, quite a few answers. They're all correct. Yep, 7 out of 10 or 0.7 is correct. Let's see. Okay, Sanvi, can you explain?
Okay, well, so I figured out that there were 10 different ways for her to get a sum. And so it was 5 choose 2, which is 10, or you could just do 1 matches up with the other numbers 4 times. So 4 plus 3 plus 2 plus 1, which is also 10. And so since there was only 10, I looked at each one of them. And so the first one was 1 and 2.
Mhm.
And that it gives us an even product. So that works. 1 and 3 does not give us an even product. 1 and 4 gives us an even product. 1 and 5 does not give us an even product. 2 and 3 gives us an even product. So does 2, 4. 2, 5 does too. Then 3, 4, but 3, 5 doesn't. And 4, 5 does. So there were 3 of these choices that did not work. So 10 minus 3 is 7. So then 7 over 10 is your answer.
Good. Yep. So this works. So if you look at, there's a total of 10 ways to choose 2 numbers, 7 of which lead to an even product. So that's a probability of 7 out of 10 or 0.7. Good. So this is one way of doing it. Did anyone do it any other way?
Another way you could do it is by complementary counting, because the only way that a product can't be even is if both numbers are odd. So we just find the probability where both numbers are odd. So since there's 3 odd numbers, we do 3 out of 5 as a chance to get the first number as odd. And then for the second one, we just do times 2 over 4, because that's the number of odd numbers that are left in the set. So once you multiply that out, you get 0.3. And you have to subtract that from 1, since this is the chance that's odd, but we're looking for the chance it's even.
Good. Yep. So yeah, the idea of complementary counting is to try to count the reverse of what you're asked and then say 1 minus that. So in this case, we're asked for the probability that the product is even. Let's say if we wanted the opposite, it would be the probability that it's odd. So 1 minus that would be the answer. And we might then think, why do we want to think about the opposite here? And the reason is it's more complicated to think about the product being even because either number could be even when I choose 2 numbers. But a product of odd is easier because both numbers must be odd for an odd product. So this is nicer because then it becomes, my denominator is the 10 ways to choose 2 numbers from the 5 numbers. But my numerator then for just an odd product would be choosing 2 numbers from the odd numbers that I have, which are 1, 3, and 5. So that just becomes 3 choose 2, or 3 is the number of ways to choose 2 numbers that have an odd product. So the probability of an odd product is just going to be 3 over 10. And then I can use the complementary counting. The probability of being even is 1 minus the probability of the product being odd. So that's 1 minus 3 over 10, which gives 7 over 10. Does this make sense? So sometimes it can be easier to count the reverse of what you're asked and subtract it from 1 or from the total number of ways if it's a counting on probability 1 minus this. So sometimes look at what you're asked and see if counting the reverse is sometimes easier. And in this case, having a probability of odd is easier because it just means choosing 2 odd numbers, and that's just 2 out of 1, 3, and 5, which is 3 choose 2 or 3. But both ways work here and give you the right answer of 7 over 10. Any questions on this? Okay, let's move on to the last question. Okay, I see one answer. Are there any other answers for this question? Okay, seems like this question was harder. So 96 isn't correct. It's actually a different answer. Let's go through this. Okay, so there's a few important points in this question. So one is Isabella received 7 different scores, each an integer between 91 and 100. And we know that she received 7 different scores. Now, the interesting part is that after each test, she noticed that the average of her test scores was an integer. And the score on the last test, or the 7th test, was a 95. We want to know what the score on her 6th test was. So let's say the scores on her tests are something A, B, C, D, E, F, and the last one we know is 95. Now, what we want to know is what was this previous one, F. Now, the important things that we know are, one, that each of these A, B, C, D, E, F are values between 91 and 100, and they're all different values from 95 also. And we know that the other important piece is that after each test, the average of her test scores was an integer. So now let's think about, so after all the tests, we know that the average was an integer. What should the average have been before she got a 95 for the average to still have been an integer? So let's say the average of the first 6 tests, so this is like A, B, C, D, E, F. Let's say this is some x. We want to know what this x is. So we can kind of work backwards. If we know what the average of those is, maybe we can use that to find the last one. And we know that the 7th test score is 95. So what is the average of all 7 test scores, given this information? Any ideas? So we're saying the average of A, B, C, D, E, F is some x. We don't know what that is yet. We want to figure out what it could be. And we know the 7th test was a 95.
95
is
x divided by 7.
Good. Yep. 95 plus, can you repeat that?
95.
Good. I think 2 of you were saying it at the same time. But yeah, I think I got it. So 95 plus 6x divided by 7 is the average of all 7 test scores. What do we know about this value? What is it?
It's an
Multiple of 7.
Good, but yeah, this value is an integer. Yep. If we multiply by 7 on both sides, then it's a multiple of 7. But yeah, we know that this value is an integer, right? So let's just say it's equal to y, to just have some variable there. So this tells us that 95 plus 6 times x is equal to 7 times y. So now what we know is this right-hand side is a multiple of 7. And we know that x and y should be integers also. And we want to know what are the possible values of x. So let's say we don't know what y is. So we know the right-hand side is a multiple of 7. We want to make sure that the left-hand side is also a multiple of 7. So we know 95, if I divide it by 7, what's the remainder?
4.
4. So because of this, we know that 95 plus 6x must be a multiple of 7. So we know 95 has a remainder of 4 when divided by 7. And if whoever is familiar with mod, this is 95 is equal or congruent to 4 mod 7. We had discussed mod before, you can look up more, but it's just a remainder, but I'll just write the notation on the side. So okay, if we know this, then what does 6x's remainder have to be when divided by 7 if 95 plus 6x is a multiple of 7?
Three.
Good, 3. So this makes sense, right? If 95 has a remainder of 4 when divided by 7, 6x should have a remainder of 3 when divided by 7 for the sum of the two to be a multiple of 7. Okay, so now we know that the average after A, B, C, D, E, F, the first 6 scores, has a remainder of 3 when divided by 7. So what does that mean about what x could be? So, and one more question here is that we know, so we know that x should be in some range, right? What range should x be in?
$91 to $100.
Good. Yeah, we know all the scores are between 91 and 100, right? So the average of the first 6 scores, A, B, C, D, E, F, should also be between 91 and 100, right? So we want to know 6 times some of those values, at least one of those values, should have a remainder of 3 when divided by 7. Which value could that be? Any ideas? So to make it easier, we can think about, so 6x has a remainder of 3 when divided by 7. So what is x's remainder when divided by 7? Any ideas? So there's no easy way, you can't just divide directly, but think about like we try different values, right? If x has a remainder of 1 when divided by 7, what would 6x's remainder when divided by 7 be? So let's just imagine that, imagine that x equals 1. So that has a remainder of 1 when divided by 7. 6x is equal to 6. So this has a remainder of 6 when divided by 7. Now what if x equals 2? What does 6x equal to? 12. What is this remainder when divided by 7?
5.
5. And you can see that this applies to, I don't need to pick 2. I could have also picked, what's another number which has a remainder of 2 when divided by 7?
9.
Good. So if I pick 9, what was 6x then?
54.
And what's its remainder when divided by 7?
5.
Good. So it stays the same, right? So it actually doesn't matter what number I pick here. If x has a remainder of 2 when divided by 7, 6x will have the same remainder when divided by 7. So I can just pick the first one and see what happens. So now if x is 3, and what should 6x be?
18.
Yep, which has a remainder of what?
4.
4. X equals 4.
24.
Good. Remainder.
3.
Okay, so now can we answer this question? We know that 6x has a remainder of 3 when divided by 7. What should x's remainder be when divided by 7?
4.
4. Okay, and now we know what range is x in.
91 through 100.
So which number between 91 and 100 has a remainder of 4 when divided by 7? Is there
94.
multiple? Huh? Good.
No.
So is there a multiple of 7 between 91 and 100?
X should be 95.
Good, 95. And the reason is because we know 91 is a multiple of 7. So remainder of 4 when divided by 7 is 95. And if you try to take the next one, that's 102. So it's not possible to have an average of 102 with scores between 91 and 100. So now if we look back, it seems like this should be pretty clear, right? So the average of the first 6 tests is 95. The 7th test score is 95. And then the average of all 7 test scores is still an integer, right? It would still be 95. So it makes sense. And we actually know that this must be the average of the first 6 tests, would have also been a 95. So now we can imagine that we can just forget about the last score being a 95. And we know that the first 6 scores, they're all different values between 91 and 100, and their average is 95. So now we can do a similar analysis to figure out what the last one should have been. Okay, so now what we want to do is we want to find what f should be. So we're kind of working backwards here. So we know now what the average of the first 6 tests are, and we want to know what the last one should be. And let's do a similar kind of logic. So now let's say, I'll pick a different variable. Let's say z is the average of the first 5 scores. So A, B, C, D, E. And so what do we know about Z? What should it be? So we don't know what exactly the value should be, but what kind of number is it?
An integer.
Integer, good. So now let's say the average of the first 5 scores is Z, and we want to know the 6th one, F. So what do we know about some relationship between Z and F and the average?
So 570 minus f divided by 5.
Is Z, good. Yep, and I'm just going to write that in a different way. So I'll just write that 95 times 6, which is 570, is 5Z plus F first, right? So what we want to know is we know the total sum of these, A, B, C, D, E, F, add up to the average of 95 times the number of numbers. There's 6 here. So 95 times 6 is the right-hand side. And we know Z is the average of A, B, C, D, E. Z times 5 plus F is 95 times 6. Okay, and what do we want to know here? What is the question asking us for?
What f is?
What F is? Okay, now looking at this, can anyone tell me what F is? Or what F could be?
It could be 95, but actually no.
So why do you think it could be 95?
If the integers, they didn't all have to be different,
Mhm.
you could take 5z, which would be, well, the average of the first 5 scores would be 95, plus f, which is also 95, equals 6 95s.
Yep, so that makes sense. But the issue is that 95 was the score on the 7th test, right? And we know that each score is a different value between 91 and 100. Okay, so we know a few things here, right? We know Z and F are both integers. The average of the first 5 scores was an integer, and the 6th score is an integer. Now, also let's look at what is a multiple of 5 here. This right-hand side is a multiple of 5. 5Z is a multiple of 5. What does that tell us about F? So yeah, I have a multiple of 5. I want to add something to it, and it should still be a multiple of 5. So what should F also be? Good. So F should also be a multiple of 5. So what should F be then? What are the possible multiples of 5 that F could be?
$100.
Good. So F has to be 100 because we know that the only multiples of 5 between 91 and 100 are 95 or 100. But 95 was already the score on the 7th test. So the 6th test score must have been 100. Okay, so this was a pretty challenging question. But the key ideas here were not too complicated. It was looking at these different things. Once we know that there's integers, we can look at what multiples they should be and what their remainders should be. This is broadly called number theory. And this is a question testing this area of number theory. And this, you can also write a lot of these expressions in terms of what we've, I think, mentioned before once or twice, is modulo arithmetic or mods. But the simple idea is just in terms of remainders. And you can look at all these expressions that combine integers in terms of what the remainder should be when divided by something. And here, looking at those carefully and kind of working backwards from the end to the previous scores allows us to find that there's actually only one choice for the 6th score, which should be 100, given that's the multiple of 5 and not equal to 95. Okay, any questions on this? Okay, then that's it for today's class. We'll see you all in 2 weeks.
Thank you. Thank you.